What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to learn about angles of elevation and depression, which sounds like a whole new topic, but really we're just doing worded trig problems. The only difference between these trig problems and the ones we've been smashing is we're actually going to have to draw the triangle. We have to interpret the question first and then draw the correct scenario and then just do our regular trigonometry from there. So the idea behind elevation and depression starts with this idea of horizontal. So I want you to imagine you're looking straight out into the distance. This is your horizontal line of sight. Then if you look up to the corner of your room, just like that, that head tilt that you just did is the angle of elevation. Looking from your horizontal sight line up, that's all the angle of elevation is. What's really important is that it's not in this part here. If I asked you to look at the corner of a room, you wouldn't look straight up and then across like some weirdo going, that's bonkers. What you would do is look straight up. That's the angle of elevation. And then the angle of depression is exactly the same. If you needed to look at something on the ground, you would look down just like that, and that's the angle of depression. Again, you wouldn't look directly at your feet and then scan up until you got it. You would look like a psycho. That's not right. So in order to answer these questions, we've got to draw the triangle first, and then our angle of elevation is just if we're looking up, and the angle of depression is if we're looking down. Sounds pretty easy. The first thing we need to do to get these right is draw the triangle and label it. And there is a massive drawing pro tip that you must follow in order to get these questions right. To make this as easy as possible, always do your horizontal line first. Go across. Like in that drawing that was excellent, we started with the horizontal line and then went up or down, and that's exactly what these drawings have to do. Draw across, elevation go up, depression go down, and then complete the triangle from there. If you don't do this, you will get the wrong answer, and this will make way more sense when you're actually going through to answer the questions. So in this example, we've got someone standing on a 60-meter cliff and they're looking out into the ocean. 200 meters away, they see a boat, and we want to work out the angle of depression. How is that guy looking at the boat out in the distance? The very first thing we need to do is draw our horizontal line, which we're always going to do first. So we're looking out, and then the boat's below the cliff, it's not floating in the air, so we know we're going down from here. Now we've got these two lines which make a right angle, we can finish off our triangle. Now we're just doing normal trig. We know that they're 200 meters away, so the horizontal line is going to be 200 meters, and it's down 60. That's how tall the cliff is. Now I've got two side lengths and an angle. This is just regular trig. Because I've got opposite and adjacent, I'm definitely using tan, and that's going to be equal to 60 over 200. To get the angle by itself, I've got to do the inverse of tan. So tan minus 1, 60 over 200. Throw it into your calculator and you'll get the right answer. So the answer for this is 16.69, and you might have to write depression in your answer. Some teachers are sticklers for that, but because it's in the question, the angle of depression, I think it's kind of implied, and this is the right answer. The reason that I'm so specific about going across first is that this question could very easily be misdrawn just by going, oh, they're on a cliff, we've got to draw that in. So for this one, I go, oh, I'm standing on a 60-meter cliff, I've got to put that in first. I'm not going to use my ruler function here because I want you to see that it looks messy because it's not right. So if I went 60 meters and then 200 meters across, this isn't the angle of depression. This would be like, hey, look at that boat, and someone looks directly at their feet and then scans across. That is completely ridiculous. So knowing that we draw across first definitely helps us, and it will get us that angle of depression exactly correct. If you did this triangle, you would get the wrong answer, and it would be harder to draw and work through. The way that we can make these questions harder is by including the person's height. In that last example, if the cliff was 60 meters tall, we would have to add on the person's height to get to their sight line. So we're going to have to include that in these calculations to get the best possible answer. So for this one, we've got a person who's 1.5 meters tall and they're looking up at a building at 18 degrees of elevation. If they're 30 meters away from the building, how tall is the building in total? Again, we're going to draw out the triangle first, and then we'll put in our labels after that. So we always start with our horizontal line. That goes all the way across, and we know we're looking up at the building, so this is definitely going to be an angle of elevation. Now all I need to do is put in this sight line to finish off the triangle, and this is all the information I need in order to get this right. So I know the person was 1.5 meters tall, so I'm going to put that in. They're 32 meters away from the building, and the angle of elevation was 18 degrees. We're trying to find the height of the building, so I'm going to put H over here, and now this is everything we need to just do a normal trig operation. So because I've got the opposite and the adjacent, we're using tan again. So tan is equal to the height of the building divided by 30. To get H by itself, I've got to times 30 to both sides. So I've got 30 times tan 18 is equal to H. All you've got to do is throw that into your calculator and you get the answer of H is equal to 9.74. But this isn't the height of the building. This is just the height from your level. So what I've got to do is add on the 1.5 to get the total height of the building. 9.74 plus 1.5 is equal to 11.24, and that's full marks for this question. That's all we've got to do. The best thing about these questions is you get heaps more marks for doing the drawing, but the mathematics is not that much harder. As long as we're drawing out first and then up and down, you're going to get these ones right every single time. We're going to learn about this one thing called alternate angles, and it's got a lot to do with elevation and depression. I want you to imagine that you're on a diving board looking down at all your friends, telling them that you're about to do a sick backflip. Your friends are looking up at you, so you've got an angle of depression to see them, and they have an angle of elevation to see you. So if we put in our two horizontal sight lines, we could actually see that we're not just making one triangle, we're actually making two. What's really important here is we've got right angles being formed because we've got a vertical and a horizontal line. These are exactly 90 degrees. So let's imagine that the angle of depression was 20 degrees down from the top down to your friends. If I asked you what this other angle down here would be, it's actually pretty easy to work out. I know that a triangle's got 180 degrees, so I've got 20 plus 90, which is 110. So that last bit has to be 70 degrees. That makes a lot of sense. That's not the only right angle that's been formed. Up there with that 20 degrees is also a right angle, and 20 of them have been used to look down. So that just means that if it's a right angle, 90 degrees, 70 must be left over. So now we've got the exact same situation. We've got a right angle triangle, 90 degrees has already been used. Then there's that 70 degrees, so that angle down the bottom must be 20 degrees large. So if I get rid of all the other information and just focus on this one bit, what you can see is that the angle of depression was 20 degrees and the alternate angle is 20 degrees of elevation. These two things are equal to each other. You might have remembered from year 7 that a Z is an alternate angle and on either sides of the line is the same angle. But what we really need to know that if you find one of these, the other person's looking up at the exact same angle, one's just going to be depression and one's elevation. Thanks so much for watching this lesson, guys, and I'll see you later.